Okay, section 9.2, second day. We got through a lot yesterday, even though it was really just this first learning target, because there's a lot of different types of these, but recognize, write, find the nth terms of arithmetic sequences, okay? Got used to that phrase, arithmetic, as well. All right, today we're going to work on these partial sums. There's a formula that will be given to you for finding these arithmetic sequences, and then we'll kind of wrap it all up with some application problems, okay? All right, so let's go ahead and take a look at example 17. We didn't do 15 and 16. I assigned it to you yesterday. This is just a recursive problem. We already did it in 9.1. So the common difference right here, it goes up 12. We're going to skip that in the notes, okay? All right, so here's our formula for the sum of a finite arithmetic sequence. Finite just means it has an end to it. It's not infinite. It's a set number of terms, okay? All right, so it just says that we need to find the sum of A1, and then A sub n will be the last term. Okay, you may want to label that here. A sub n is going to be the last term. All right, and then n is going to be the number of terms. If you're finding the sum of the first, 50 terms, so n will be 50. We do 50 over 2. So they're going to tell you the number of terms. And if I said 50, then this would probably be A sub 50. Okay. All right, so let's take a look at 17. Let me walk you through this here. All right, what do I have right now? Right now, they give me n is 50, so I know I have that. Do I have A sub 1? Sure, I do. The first term of the sequence is listed right here as 9. So what are we missing? We're missing A sub n. I'm missing A sub 50. If I want to find the first 50 terms, the formula says I need that last term, A50. So we need A sub n, or in this case, A50. Something you want to realize right away. Okay. All right, so we're going to use the skills from yesterday to go find A50. Okay. So just to make sure we're clear, we're going to use this formula. A sub m equals A1 plus n minus 1 times the common difference. Okay. All right, so let's plug in what we're looking for. We're looking for A50 equals A1, 9 plus n minus 1, so that's 50 minus 1, times the common difference. So you got to look to the sequence and figure that out. Okay, and we can see that 12 is being added to get to the next term, or you could subtract these to double check. So 12. And sometimes we simplify the formula, but since we're just trying to get A50, this would be enough. All right, so then we do the math. 49 times 12, we add 9. I have the number here. It's 597, but just dump it in your calculator to get it. Okay. All right, now I have everything I need to find the sum. So I'll just kind of block these off. So I realize there's 2 separate steps. So here we go. S of n, so S of 50 equals, the next thing it says is 50, or n over 2, so 50 over 2. And then it says times the sum of A sub 1, which was 9, plus A sub n, which we needed to find first, and now we have it. It's 597. Okay. And you don't have to get too fancy here with this. I mean, you can just dump this in the calculator now. I guess if you wanted to find the sum first and have 25, that's basically what we're going to have, right? So I've got 25 times the sum of 9 plus the 597. And we multiply those and we get this sum, 15,150. So S of 50 is 15,150. Okay, now we had sums of sequences in 9-1, but they were relatively small and we just had to add them up manually. But now that it's arithmetic, we have a formula, so we don't have to actually add up all of these terms. That would take a long time to do, and we'd have a lot of terms to find. So thankfully, this formula makes our job a little easier on that. Okay? All right, block off 18 over here. You guys go ahead and try 18. Pause at home and give it a shot. All right. This time I simplified it just to kind of review what we did before, because you could distribute the -8 to get this. All right, but you can plug in 100 earlier in the process if you want. Just make sure we're getting -827 for that number. Okay. All right, so now we're ready. S of 100, that means the S sum of the first 100 terms is equal to n over 2, and then tried to squeeze that in there. I was almost running out of room. A1 plus A sub n. Okay, do the math, go to the calculator, we get -43,100. Okay, so how's 19 and 20 different? The directions are still the same. Find the partial sum of the arithmetic sequence. It says partial because really every sequence, this technically goes on forever, right? We could, but they stop at 50, so that's why it's partial. 19, remember what summation notation means. Find the sum from term 1 up to term 70 for this formula. Now, manually, like in the last section, that would take a while. They usually only said like 1 to 5, so you only had to do 5 terms, add them together. But here's the catch. They told us it's arithmetic. We have a formula now. We definitely don't have to find all 70 terms. What do we need? These 3 things. N, A1, and A sub n. Can we get those? Absolutely. All right, so that's what you got to realize. I got to start gathering information. What's N right away? 70. 70 terms from 1 to 70. Well, what's A1? I don't know, but we can go find it. And what's A sub n? And A sub n in this case is going to be A70. If I get those next 2 things, we're ready for the formula, okay? All right, so how to get A1? The formula is right here. So 2 times 1 plus 5, 7. A70 is going to be 2 times 70 plus 5. So what's that? 140 plus 5. So 145. All right. So what's different about this one, it's actually easier if you remember summation notation because the formula is already given to you. Up in 17 and 18, we had to create our own formula. It's already done. So the sum of the first 70 terms will be equal to n over 2, so 70 over 2, times the sum of a sub 1, 7, plus a sub n, 145. Okay, so I've got 35 times that sum. I mean, you could simplify it and put the 35 times the 152 if you want, or you could just punch it in like this too. You could even do the 70 over 2, parentheses, and then put the next 7 plus 145. Okay, and we're going to get our answer, what that's going to be. So S of 70 is 5,320. Okay, pause and try 20. All right, this one you could pretty much do without even touching a calculator. Plugging in 1, pretty easy to do that one. Plugging in 200, 300. And now we're ready to go ahead and start the formula. So half of 200 is the 100. This is easily 799. And multiplying things by 100, just add 2 zeros. So that one is pretty easy on the mental math. Okay, 21 and 22, we're going to take these now and apply some real-world applications. So let's take a moment here to read 21 to yourself. Read 21. Okay, some keywords we need to recognize. Increasing sales by a constant amount each year. They're describing arithmetic sequences here. When you increase something by a constant amount, it's a common difference. They just gave us the common difference. Then they also asked for the total sales during the first 10 years. So that means we need A10. Because right now, if we wanted to find the total sales, think about what we have. We know what N is. They said 10 years. We do know the first term of the sequence. It starts off with $10,000 in sales, but we don't know the 10th year yet, and we need to go find that. Okay, and we can. This is just like 17 and 18, basically. All right, because 21 is starting off with 10,000 is right there, and then it's increasing, right, by a set amount. So let's find A10 first. So here's our A sub n formula. A sub n equals A1 plus n minus 1 times the common difference. And that was explained as an annual increase of 7,500. Okay, now, like I said, we could skip simplifying. Let's just go ahead and plug in 10 to get that sales that year. So 10 minus 1, we get 9. That makes sense, right? 9 consecutive more years of these increases added to the first year. So that gives us 77,500 in sales. Okay, so just like the other problems, we're set. We have everything we need now for that sum formula. Okay, it'll take a while, obviously, to add up all 10 years and find all those terms in between. This is a major time saver. So S of n, sum of 10 years equals 10 over 2 times A1 plus the A sub n, which we just found is 77,500. Okay, and I have the number here. You know how to punch these in by now. So here it is. Adding up those 10 years of sales is 437,500. Put a little context here. In total sales. Sorry, it's kind of sloppy. I was trying to squeeze it in. Total sales, what that reads. Okay, 22, just a kind of a new setting, but it's very similar in terms of the flow. You need to figure out the last term, and then once you have that last term, you'll be able to find the sum. Okay, give yourself about 3 or 4 minutes to give that a shot. Okay, so we need the 7th year salary. A1 plus n minus 1 times the common difference, which was explained as a $1,500 raise each year. So there we go. Plug in 7. Here's the 7th year salary. If you didn't get that, jot that down and make sure you figure out how to get there. 51,500, skill we worked on in yesterday's assignment. All right, now we have everything we need because we have A1, we have A7, and we have the number of years, 7 years. So total compensation, here we go, 329,000.